So in our yesterday class we have discussed about the equivalent focal length and cardinal points for our coaxial lens system. So this was our slide. So we had taken the two lens systems and an object O is located somewhere u distance at u distance. So the image formed by the first lens is an I dash, and later on it will behave like a virtual object for lens 2, and the final image is formed at I. So this we have already discussed in our last lecture. We had determined the values of the coefficient for the generalized equation. So these were our coefficient b upon a and c upon a d upon a, which are in terms of cardinal point and focal equivalent focal length. If we take or if we have to calculate the value of beta and alpha or capital F, so for that we have to do just some mathematics. Okay, just multiply, or we can say on multiplying equation 6 and equation 7. So our equation 6 is this, and left terms of equation 7 is minus alpha plus capital F. On the right hand side, multiply b upon a multiply by c upon a. Alright, so this becomes, so the final value become, just multiply of alpha and beta. So negative negative positive, alpha beta, then beta capital F, then negative negative positive, alpha capital F, negative alpha F square, which is equals to b into c upon c. This is equation number 9. Alright, now I just subtract equation 9 and 8. Why? Just mean I have to calculate F square. I need to calculate F. Your capital F is equivalent focal length. Alright, subtracting just simply write, we just subtracting equation 9 to equation 8, 9 minus 8. So 9 is our alpha beta minus beta capital F plus alpha capital F minus F square. Our equation 8 is left hand side on equation 8. This is this negative of alpha beta minus minus plus beta capital F minus of alpha capital F. This here becomes b cross c upon a square minus of dA. Alright, now just cancel, alpha positive negative cancel out, then beta negative positive cancel out, alpha negative positive cancel out. So the final term is we have minus of F square, which is b cross c upon a square minus of d upon a. On multiplying, minus 1 both the side. So the equation becomes capital F square equals to d upon a d upon a negative of b cross c upon a square. Alright, on taking the LCM we will get capital F square becomes d multiplied by a minus b cross c upon a square. Alright, so now we only have to put the value of d, a, b and C. Alright. If you remember, we had just assumed these value of D was your minus of D F1 F2. Value of A is D minus F1 F2, and value of B is F1 F2 minus D F2, and C is D F1 minus F1 F2. These all value are here. Just go through our last video or here. This is my value of A, this is value of B, this is value of C, this is value of D. Just substitute these value here in equation. Say this equation, I say if last equation was 9, so this equation 10. Alright, if we substitute this, just let me zoom this. F square value of D is minus of D F1 F2 multiply A is D F1 minus F2, minus of B is F1 F2 minus D F2, C is D F1 minus F1 F2. On denominator it is value of A is D minus F1 minus F2 to the power 2. Just simplify this, we will get F square is something minus D square F1 F2 plus D F1 square F2 plus D F1 F2 whole square minus of D F1 square F2. Just multiply these things plus F1 whole square F2 whole square plus D square F1 F2 minus of last term D F1 F2 whole square, and at the last LCM is which was our df1 f2 to the power 2. Alright, so on just simplification we will get, see, this term is cancel out, f1 this term cancel out, and this term cancel out. So the final value will be have capital F square is equals to f1 whole square plus f2 square upon d f1 minus f to the power 2. On taking LCM we will, or sorry, not on taking square root plus minus value of f1 f2 upon d minus f1 minus f2. Just all the, we will only take the positive value. Why? Because it is true for all the values of d. It will true for all the values of d. So the equivalent focal length must be f1 f2 upon d minus f1 minus f2, or capital F becomes 1 upon capital F becomes 1 upon f1 plus 1 upon f2 minus d of f1 f2. We all are familiar with this formula, which is nothing but equivalent focal length. Equivalent focal length. All right. On Moon's simplification, we will get, if we have to calculate the value of f1, f2, say f1 plus f2 minus d, which is again f1 f2 upon capital F. If we remember from equation 7, what we have, minus alpha plus equivalent focal length is equals to c upon a. This is our equation number 7. This one, I just picked this equation 7 here. Or alpha can be written as minus of c upon a plus capital F. All right. I know the individual value of c, individual value of f, a, and individual value of f. Just substitute this, all these value, and we'll get alpha become something like positive of d capital, sorry, small f1, just f1 upon f1 plus f2 minus d. If you remember, I had written f1 plus f2 minus d was f1 f2 upon capital F. Just substitute this value, so the final our alpha, one cardinal point becomes positive of d capital F equivalent focal length upon f2. So this is our first cardinal point. All right, now for the second, just write thus, the first principal plane is to the right of the first lens. So on a principal axis, if this is our lens L1, so the first cardinal point, the first principal plane is to the right of the first lens. If this is my first line, so it will lie somewhere here, first principal plane. All right. If we take equation 6, same, from equation 6 we know this is beta minus capital is b upon a. All right, so if I need to calculate the value of beta, which becomes b upon a minus plus f, which is equivalent focal capital F. All right, substitute the value of individual value of b, capital A and capital F. We'll get something d of f2 upon f1 plus f2 minus of d. We already know f1 plus f2 minus d is f1 f2 upon capital F. Just substitute this value here, so the beta becomes where minus of d capital F, which is an equivalent focal length, upon f1. So this is our second cardinal point. So this is our second principal plane, the position of the second principal plane. Thus the second principal plane is to the left of the second lens Alright, just because of negative sign. So say if this is our L1, if this is our lens 2, so the first principal plane will lie somewhere here. Say this is B1 to the just right to the lens system 1, or we can say it will lie right to the lens 1, and from this negative side we can say the L2, so the principal plane, second principal plane will lie on the left side of lens 2. Say this is somewhere here. All right. So this is our alpha and beta, and we can say these are the cardinal point for our cardinal point system. And if we see, or just to implement this in some numerical, just take a numerical. Say a question says, suppose a question says, take it as a coaxial lens system placed in air has two lenses of focal length of 3f and capital F. Alright, separated by a distance 2f. Alright, find the position of the cardinal point. Find the position of the cardinal point. So the question says we have a coaxial lens system, two lenses L1 L2 of focal length 3f and f. I just make lenses as a straight line. All right, and the distance between two lenses is 2f. Right, we need to calculate the position of the cardinal point. So if we solve this, what we have f1 is 3f, f2 is capital F. Separation is d, which is 2f. If we need to calculate the first equivalent focal length, so 1 upon capital F is 1 upon f1 plus 1 upon f2 minus of d, f1 f2. Just substitute these value here. So 1 upon capital F becomes 1 upon f is 3f. All right, plus 1 upon f minus of d is 2f upon 3f multiply my f. Will cancel this f1, so the equation becomes 1 upon 3f plus 1 upon f minus of 2 upon 3f. Just take the LCM 3f. 1 plus 3 minus 2 becomes 2 3f. 1 upon f, so the equivalent focal length is 3f upon 2. All right, equivalent focal length is 2. For the principal plane, alpha we know alpha, how much alpha? D plus d of capital F upon f. D of capital F upon f2. For beta, which was minus d of capital F upon f1. Now just substitute the value. D was your 2f, capital F is 3f upon 2, f2 is your capital F. Just f in cancel out 2, so this becomes 3f. So alpha becomes 3f and beta is minus of d. D is your 2f multiplied by equivalent focal length, equivalent 3 upon 2 capital M, f1 is 3f, f will cancel out this f, lu becomes minus of f. So the beta is, alright, so the alpha 3f says this thing justified that the first principle, the first principle, first principal point, say p1, is at a distance how much, 3f to the, just because of positive sign it is of 3f to the right side, to the right side of the first lens, and beta equals to minus f says that the second principal point, say p2, is at distance f to the left, just because of negative sign, to the left of the second lens. All right, so this is our cardinal point and equivalent focal length for a coaxial lens system. So we had calculated the value of alpha and beta, and we had just implemented in one numerical. So this cardinal point alpha and beta is going to be used in high gains and Ramsden eyepiece, just to calculate the cardinal point of these eyepieces. So on the next lecture we will discuss the cardinal point for Ramsden or high gains eyepiece. Thank you.